Hi, and welcome to CyberInks. I'm your host, Rose, and today we're talking about network fundamentals. Let's go. So, if you are new to the technology world, you may have seen and heard the word network or networking within your job or school. But what does that actually mean? Think of your home. You might have a laptop, maybe a mobile phone, a smart TV, maybe even a smart fridge. You may notice that if you connect your phone and TV to the Wi-Fi, you'll be able to send YouTube videos on your big screen. It's almost like these devices can speak to each other. And the reality is, they can. And this is all down to a little machine that is currently in your house called the router. Your router creates a network called a LAN, which stands for Local Area Network. And that's really what it is. It's the local connection creating a network of all your Wi-Fi devices and Ethernet connected devices so they can communicate with each other at ease. In a company, the network engineers and architects will install a much bigger structure than what you have in your house. However, the concept remains the same. It's all about creating many different LANs. Maybe a LAN for the marketing team, a LAN for the printers, a LAN for the Wi-Fi devices, and so on. Well, that sounds like a lot of routers in one place. So how do they manage it? The way companies manage this is to purchase something called a switch. On these devices, you basically plug in all your devices into it, as you do at home, using the Ethernet ports, and you can segregate these ports by configuring a lot of LANs, up to 4,094 to be exact. And these are called VLANs, short for virtual LANs. A company can have a lot of switches, and these are all connected to something called the router. But wait a second, we mentioned before that the device in your home is also a router. And that's right, your home does not need a lot of traffic. The switch, router and Wi-Fi antennas are all bundled into one machine, whereas within a company, this needs to be spaced out to handle much larger amounts of traffic. A switch does not just split devices plugged into its Ethernet ports into VLANs, however, it can also tell traffic where to go. Every physical device you have has a hardware-based identifier unique to the device's network interface. That identifier is called a MAC address, short for Media Access Control. This MAC address can be communicated to other devices, but only within the local network, also known as the private network. And it looks a little like this. The first 6 characters represents the company that made the network interface, and the last 6 is a unique number. Your devices also have something called an IP address, also known as the IP version 4 address. An IP address is a way of permanently or temporarily fixing an identification number to the MAC address to reach outside of the network. And it looks a little like this. These IP addresses are used by routers to route the correct traffic to the correct place, either internally in your network or externally out to the internet. An IP address has both local addresses and public addresses. Local addresses are routable within the site, and public addresses are routable outside of the site. The reason why we have both public and private addresses is due to human error at the start of the internet. When the internet was first created, people assumed that it would be very unlikely for the whole world to need more than 24,868,000 IP addresses. Here are the current ranges that they were using and we currently still use. I don't need to tell you that they were wrong. As the internet quickly expanded, these addresses were being used up quickly. The quick band-aid solution was to have the original ranges only for use within one LAN at a time. If they wanted to reach the internet, they will need to buy a public IP address provided by your Internet Service Provider or ISP, which internal private IP address could be translated to. For example, 20 private IP addresses local to your home can be translated into just one public IP address to reach out to the internet. And this is specific to your home network. This is called NATing, which is Network Address Translation. Currently, there is over 4.3 billion public addresses. However, this is a finite and largely exhausted pool. There has actually been a creation of another range of public addresses called an IPv version 6 address, which has 340 undecillion addresses, but it's not yet widely used. So, to put everything together, the public IP is used to get to the correct network on the internet, and the private IP is used to get the traffic to the correct switch, and the MAC address is used to deliver the traffic to the specific device within that switch. Now, this is a cybersecurity course, and we also need to speak about how to protect a company using the concept which you've learned in this lesson. Previously, we spoke about MAC addresses. Imagine if I was a hacker and I used a fake MAC address which was the same MAC address as your laptop in an unsecured guest or public Wi-Fi. I could maybe perform scans to gather information about connected devices, or maybe I could even have unauthorized access into a device. In 2016 in Bangladesh, there was a bank heist where the attacker changed their device MAC address to match one of the bank employees' devices, gaining unauthorized access to the SWIFT payment system and executing fraudulent transaction. This is called MAC address spoofing. So, how would a company protect themselves against this? Some ways to protect against this is to encrypt any data the attacker can get his or her hands on, put firewalls in place to restrict network access, and also to enhance port security on the actual Ethernet port itself. We have also spoken about IP addresses, which an attacker can also spoof. They can create traffic with changed IP addresses. This type of attack happened to GitHub in 2018 and Google in 2020. A company can protect themselves by using intrusion detection systems. This can monitor traffic for suspicious behavior and can block spoofed traffic, can filter IPs within your company, also make sure security patches are up to date, and use strong protocols to stop attackers from modifying traffic. Now, this has been a very high-level view of networking and how everything fits together. And as a security manager, it is needed that you have a basic understanding of these concepts to give correct instructions to your team or security program which you manage. However, if you're planning on moving into a more technical role in cybersecurity, it is essential that you understand the flow of traffic through the networks in detail. But don't worry, we will go into deeper concepts for networking and traffic flow related to cybersecurity in the following lessons in this course. So, when you're ready, grab a coffee and I will see you in the next session.